Welcome to this explainer. Today, we're diving straight into the often blurry lines between what's strictly legal and what's actually moral for us as future engineers. When you're deep in your studies, it's super easy to view engineering purely as this world of hard math, physical laws, and absolute certainties. But honestly, as soon as you step out of the classroom and into the professional world, the equations get a whole lot messier. You'll quickly find out that human behavior, business pressures, and public safety, well, they just don't fit neatly into a spreadsheet. So today, we're going to unpack some real-world ethical dilemmas where the rulebook might tell you one thing, but your conscience is screaming another.
Let's kick things off with a dilemma I think we can all relate to. If you download a super expensive piece of software for free, is it ethically any different than just walking into a convenience store and pocketing a candy bar? It sounds kind of wild to compare the two at first, right? But it actually gets right to the core of how we justify our everyday actions. As students or, young professionals on a tight budget, we face these micro decisions all the time. But how we answer this seemingly small question actually builds the foundation for how we're going to handle much bigger, literally life or death decisions later on in our careers.
All right, moving on to Section 1, Law versus Morality, Finding the Baseline. To really answer that candy bar question, we first need to test a huge assumption. We often mistakenly assume the law is a perfect mirror for morality. But is it? Like, if you check the books and find absolutely no law against a certain action, does that give you a free pass to do it? Or, on the flip side, if the law strictly forbids something, does that make the action inherently evil? As we're about to see, the real world is packed with situations where the law is completely out of sync with what's actually right.
And this brings us to a really simple analogy that perfectly illustrates the difference. Imagine you're flying down the highway going way over the speed limit just because you overslept and don't want to miss your engineering lecture. Obviously, you're breaking the law, you're acting unethically by endangering everyone around you, and frankly, it's just bad form. But let's shift the context. What if you have a passenger in the back seat who's actively bleeding out and you are rushing them to the emergency room? You are breaking the exact same traffic law. The legal penalty is technically the same, but ethically, morally, every single one of us would agree that saving a life absolutely justifies breaking that speed limit. The action is illegal, for sure, but it is deeply, deeply moral. Okay, so that brings us to Section 2, Piracy versus Physical Theft, the Rationalization Trap.
In our source case study, an engineering student named Ahmed justifies pirating software to his friend using some very familiar mental gymnastics to prove he isn't stealing. First off, he claims the software is just way too expensive, kind of implying he's the victim of corporate greed. Second, he argues the company hasn't actually lost a sale because, hey, he wouldn't have bought it anyway. And third, the absolute classic defense, it's just pixels on a screen. No physical object was taken off a shelf, so it's a victimless crime, right? Well, this is basically a masterclass in rationalization.
But look at this scenario. Imagine Ahmed just walks out of a store with an unpaid candy bar. We have to ask ourselves, does a tight student budget justify ignoring ethical reality? If Ahmed grabbed a chocolate bar, looked the cashier dead in the eye, said, "It's too expensive, I wouldn't have bought it anyway," and just walked out, we'd all instantly call that theft. The source material challenges us to recognize that the intellectual property behind that software took thousands of hours of intense engineering work to build, work that you, as future engineers, will absolutely expect to be paid for one day. So whether it's lines of code or a piece of chocolate, taking the product of someone else's labor without paying for it is ethically problematic, no matter what mental gymnastics we use to help us sleep at night. Let's escalate things. Section 3, Legal but Immoral Loopholes, Escalating the Stakes. Imagine a chemical company develops a brand new process, but it produces a highly toxic, cancer-causing waste. But here's the catch. Technically, it falls completely outside the definition of the government's banned list, simply because it's so new. The company's own internal studies show exactly how dangerous it is. But because it's a completely new formulation, the traditionally slow-moving government regulators just haven't had a chance to study it and add it to the prohibited list yet. So the company's lawyers swoop in and point out a massive loophole. Dumping this toxic sludge into the local environment violates absolutely zero current laws. So the crucial point is right here. While dumping this unlisted chemical is technically legal, it is an absolutely immoral and unethical loophole to exploit. Think about it. This is the exact opposite of our hospital speeding example. There, we had an illegal act that was highly moral. Here, we have a perfectly legal act that is profoundly immoral. If an engineer signs off on dumping this waste, they might be fully shielded from going to jail, but they are knowingly poisoning a community. And that is exactly where your personal code of ethics has to step in to fill the massive voids left by the legal system.
Which leads perfectly into Section 4, the bridge safety dilemma, career versus conscience. Let's put you in the hot seat. As a professional engineer, your employer demands you design a new bridge, and they give you a brutal, strict budget constraint that absolutely cannot exceed $1 million. Not one penny more. You're tasked with making all the math work, picking the materials, and ensuring the structural integrity, all while keeping the accounting department happy. But here's where it gets scary. Your engineering studies reveal a terrifying trade-off. You've crunched the numbers, you've run the simulations, and the data is completely clear. An ideal, genuinely safe bridge costs $1.5 million. If you force the design to fit that $1 million mandate, you're going to have to cut some major critical corners. In fact, you know for a scientific fact that the budget bridge will guaranteed collapse if even a moderate earthquake hits the region. And then, your boss delivers this chilling threat. They force you to weigh human lives against the livelihood of your own colleagues. You take your findings to management, assuming they'll just ask for more funding, right? But instead, they hit you with this. They make it incredibly personal. It's not just about corporate profits anymore, it's about the people you eat lunch with every single day. If you refuse to build the cheap bridge, the company loses the contract, people lose their mortgages, their health insurance, and you lose your job. So now, you are trapped in a severe professional crisis. What is the conflict here? Is your primary duty to your fellow employees and the financial health of your firm? Or is it to your own career survival? Or actually, scratch that, does your ultimate duty lie with the thousands of completely innocent drivers who will cross that bridge every single day, totally unaware of the structural compromises you made behind closed doors? Let's answer that in Section 5, the engineer's ultimate duty, resolving the conflict. When the stakes are this high, what's more important? Well, the source material draws a hard line here. It clearly states that in a case like this, the welfare of society must absolutely come first, entirely overriding any loyalty to your firm. Look, the economic pain of losing a job or seeing your friends laid off is incredibly real and it's devastating. But it simply cannot be weighed against the mass casualties of a collapsing bridge. The loss of human life and the betrayal of public trust is the ultimate evil in engineering. You absolutely must refuse to build the unsafe bridge. And this quote right here from your professional code of ethics serves as your ultimate compass. Public safety isn't just a nice suggestion. It is of paramount importance. Not secondary, not important when the budget happens to allow for it. Paramount. When you design a bridge or a chemical plant or the software that keeps an airplane in the sky, the public assumes you have put their safety above your company's stock price and your own paycheck. That trust, that is the entire foundation of the engineering profession. So, as you prepare to head out there and enter the professional engineering workforce, I want to leave you with this final provocative thought. It is so easy to be ethical when it costs you absolutely nothing. It's easy to sit here and say you wouldn't pirate software or that you'd never dump toxic chemicals. But the true test of your engineering ethics? It's not going to happen on a multiple choice exam. It's going to happen on a random Tuesday afternoon when your boss is yelling, the budget is totally blown, and you have to decide whether to sign your name to a design you know is fundamentally compromised. When that day comes and your career and your conscience collide, which one will you protect?